Okay, now we're going to start examples on doing the derivative of a function as a function. So the derivative of our function is now going to be, again, a function. Okay, so we're going to find this derivative by definition. The derivative of g at x is nothing but the limit as h approaches 0 of g of x plus h, now not a, just any x, minus g of x all over h. In this example, our function is g of x equals square root of 2x plus 1. So we replace x plus h in the function for x. So here, instead of x, we replace by x plus h. To the limit as h approaches 0, g of x plus h is the square root of 2 times x plus h plus 1. Then minus g of x is just the same function. So is square root of x plus 1 all over h. Now we just distribute the 2. That's the limit as h approaches 0 of the square root of 2x plus 2h plus 1 minus the square root of 2x plus 1 all over h. And have you seen before, every time we have two terms and at least one has a square root, the procedure is we go ahead and multiply and divide by the conjugate, which is the same two terms but with opposite signs. Plus 1 plus, so the same two terms. And we also have to divide by the same number. Square root of 2x plus 2h plus 1 plus the square root of 2x plus 1. Okay, let's go a little bit into what this conjugate means in case you have not gotten it yet. So suppose this is a and this is b. So you have two terms. They are subtracting. So the idea is multiply by the conjugate. This plus this. So the same a, the same b, and we do the conjugate. Because this formula is just the difference of squares. When you FOIL this product, you get a squared minus b squared. So that's the idea. Once you square the two terms, you get rid of that square root and be able to unlock the x and the h from the radical. So let's go ahead and do that. We have here that this is the limit as h approaches 0. And you see, this says take the first term, which is square root of 2x plus 2h plus 1, and square it, and then subtract the square of the second term, 2x plus 1 squared. And in the denominator, you're going to multiply the two denominators. So that's h times square root of 2x plus 2h plus 1 plus square root of 2x plus 1. And then this is the limit as h approaches 0. This is done so that the square root cancels out with the square, and here the same thing. So in the numerator we get 2x plus 2h plus 1 minus, keep always a parenthesis there. That negative sign is always going to change all signs inside. So the best idea is keep your parentheses there and then you change the sign so you don't make mistakes. This is h times square root of 2x plus 2h plus 1 plus square root of 2x plus 1. And so we get the limit as h approaches 0 of 2x plus 2h plus 1 minus 2x minus 1. And in the denominator, we just get the same thing. Let's see if I can just duplicate this. So the 1's cancel out, the 2x cancel out, and we're left with the limit as h approaches 0 of 2h divided by h times, same thing, square root of 2x plus 2h plus 1 plus square root of 2x plus 1. The h is cancelled out, and this reduces to the limit as h approaches 0 of 2 divided by square root of 2x plus 2h, plus 1 plus square root of 2x plus 1. And now we take the limit. When we plug in h equals 0, this disappears, and we get 2 over square root of 2x plus 1 plus square root of 2x plus 1, which gives us 2 over 2 square root of 2x plus 1. And then we can conclude that the function derivative of g at x is 1 over square root of 2x plus 1. So the first part of the problem, we found the function derivative of g of x, which was 1 over square root of 2x plus 1. Now the second part asks us to find the tangent line at x equals 0 and at x equals 4. So the derivative is the slope of the tangent line. So if we evaluate the derivative at 0, we will get the slope of the tangent line at 0. In this example is 1 over square root of 2 times 0 plus 1, that is nothing but, well, 1 over square root of 1, which is 1. This is the slope of the tangent line. So we're looking for the line whose slope is 1, and we need to find the point. The point is 0, g of 0. So we just have to evaluate the function at 0 to find the y-coordinate. So that's square root of 2 times 0 plus 1, and that again is 1. So the point of tangency is 0, 1. And then the tangent line, we use the point slope formula, which is y minus y1 equals mx minus x1. Recall this is x1, this is y1, and the slope is 1, so we get 1 minus y1, which is 1, equals m, which is 1, times x minus x1, which is 0. So that's y equal 1 times x, and then I add the 1 on both sides, plus 1. This is the tangent line. This tangent line to g of x at x equals 0. To finalize the problem, we want to find the tangent line, but now at x equals 4. Again, we know that our derivative is 1 over square root of 2x plus 1. To find the slope of the tangent line, what we do is we evaluate the derivative at 4. So that's 1 over square root of 2 times 4 plus 1, which is 1 over square root of 9, which is 1/3. That's the slope. A point has an x-coordinate of 4 and a y-coordinate given by g of 4. So we go to the original function and evaluate at 4. So that's going to be square root of 2 times 4 plus 1, which is square root of 9, which is 3. So the point of tangency is going to be 4, 3. To find the tangent line, we use the point slope form of the line, equals mx minus x1. Recall this is x1, this is y1. So this is y minus y1 is 3, and that equals 1/3 x minus 4. Then y equals 1/3 x minus 4/3. I'm adding the 3 on both sides, plus 3. So y equals 1/3 x, and then negative 4/3 plus 3 is what? 5 over 3. And this is the equation of the tangent line. So this is the tangent line to g of x at the point 4, 3. Thank you.